MZ Institute of Engineering and Technology in Department of Electronics and Communication. This video is about subject fiber optic communication. So friends, in the last video, you learned about the various topics related to the fiber optic communication. Now, we need to study about few more topics related to the fiber optic communication. So friends, in this video, we are going to discuss about the few concepts related to the optical fiber structures, waveguiding and the fabrication. Now as we know that the light which is traveling at the constant speed, but it's not like that. It depends on to the various kind of the material. In this subject, we need to study about how the light traveling from the fiber optic cable or the fiber optics. Before that, we should have the idea about the few topics related to the light optics. The speed of the light in the free space, that is around the 3 into 10 raised to 8 meter per second. But now, while the material has been changed, the speed of the light that may be changed. So, here we are going to discuss about the few optical laws, definitions, and mainly we will discuss regarding the reflection, refraction and the Snell's law. So friends, what is the reflection? What is the refraction? So, as we know that the reflection, you can see over here the emojis, okay, that is the one emoji, okay, look at inside the mirror, the reflection of itself, it happened, okay, in the particular scene. So that is about the reflection. So what is basically it? So whenever the homogeneous medium is there, the light rays are the straight line and light may be absorbed or it is reflected. So this particular thing is referred to as a reflection. So now here you can see that the normal axis or the reflection axis. Now while the incident ray traveling from the particular medium. So here you can see that the medium, that is suppose the having the refractive index, that is the N2. Now this is the incident angle, okay. Now there is an incident angle, okay, and it was referred to as an incident ray, and there is a light source. Now when the homogeneous medium is there, now you can see over here the particular medium, okay, the incident ray will make the angle with the normal is the theta 1. Now it is reflected. So this is known as the reflected ray. It makes the angle with the normal axis, that's a theta 2. So theta 1 and the theta 2, they are the angle of the incidence and angle of the reflection. So whenever the homogeneous medium is there, there is a reflection. Okay, so reflected ray lies in the plane of the incidence and the angle of incidence will be remain same as the angle of reflection. So now it is about the reflection. Now whenever the two mediums are different, mean the ray will traveling from the medium, that is suppose the denser medium, and it travel into the rarer medium or sometime from the rarer medium to the denser medium. So whenever the light will pass from the one medium to another medium, the refraction would occur, and this refraction is the change in the direction of the light. Okay, so that is the simple fundamental. We will study more about the refraction later, but right now the definition of the refraction. So here you can see in the diagram that there is a normal axis, the incident ray, okay, now that is in the one of the medium, okay, now when it passes from the one medium to the another medium, the ray will bend. The ray will bend, okay, and here the angle it will make, it's the angle of refraction, and here the angle of the incidence, okay. So this way the refraction will occur while the medium is not same, and the reflection would occur while the medium is same. So now this relationship between the angle of the incidences that described by the law that is referred to as a Snell's law. So now we will study about it. So here you can see in the diagram the refractive index, that is the N1. How can we calculate the refractive index? It's eta is equal to C upon V. Okay. So while the ray will travel, okay, into the different medium, the speed of the light that can be changed, and from we can have the idea about the speed of the light from this particular the index. So air and the water. So here you can see that the theta 1 it's the angle of the incidence, and theta 2 that is the angle of the reflection. Okay, so here the medium is air having the refractive index N1, and the medium N2 that is having the refractive index, it's a N2. So when the light passes from the one transparent material to another, it bends according to the Snell's law, and which is defined as N1 sin theta 1 plus N is equal to N2 sin theta 2, while N1 and N2 that are the refractive index of the medium the way the light is leaving. Theta 1 that's the incident angle between the light beam and the normal axis. Theta 2 that is again the refractive angle between the light ray and the normal, and N2 that is refractive index of the medium when the light is entering. So what is Snell's law? N1 sin theta 1 is equal to N2 sin theta 2. So N1 sin theta 1. Now while the N1 is less than N2, refractive index of the one medium that is less than the refractive index of the another medium, the ray will bend, okay, towards the normal. And when the N1 is greater than N2, the ray will go away from the normal axis. So this way the Snell's law gives the idea about it. So here the N1 sin theta 1 is equal to N2 sin theta 2. Okay, so it is N1 divided by N2 is equal to sin theta 2 upon sin theta 1. Okay, now we know that what is N1? It's a C upon the V1. Okay, and N2 is equal to C upon V2. So now putting this value in the equation number 1. So by putting this, it is N1 sin theta 1 equal to N2 sin theta 2. So it is C upon V1 upon C upon V2 is equal to sin theta 2 upon sin theta 1. Okay, and is equal to V2 by V1 is equal to sin theta 2 upon sin theta 1. So it is the equation number 2. So it is the, okay, regarding how the ray will bend, okay, towards the normal or will go away from the normal. Okay, so it is about, we can decide it by learning the Snell's law. Now the second important aspect, that is about the critical angle. Okay, so what is the critical angle? So it is the angle of the incidence of a ray while the light moving from the denser medium to the rarer medium, such that the angle of the refraction that becomes 90 degree. So the critical angle, that is the angle of the incidence, increases to the angle of the refraction changes. So the ability of the refracted light is represented by the optical density of the medium. So while the light ray with the different velocity in the different medium, it depends the optical density of the medium. So optical density, okay, that plays a big role, okay, onto the speed of the light. Okay, so it is classified into the two categories, denser medium and the rarer medium. Okay, so now the denser medium. Okay, so when the optically denser medium is there, the speed of the light is less. Okay, so that is suppose the water. Now optically rarer medium, that is the medium in which the speed of the light is more, mean it's a air. So denser and the rarer medium don't depend upon the density of the medium. Okay, so at a certain angle of the incidence, keep in mind, at a certain angle of the incidence, okay, the angle of the refraction that becomes the 90 degree, and the reflected light that lies along the interface or the boundary of the two medium, and this is known as the critical angle. So now here in the diagram you can see, in the first diagram you can see the medium having the refractive index N2 and the N1, okay, air and the water, you can see that. Okay, now what happened, that while the ray will travel from the water to the air, mean the denser to the rarer medium. So here you can see that the theta 1, that's the incident angle. Okay, now it will traveling from the denser to the rarer medium. So you can see that the refracted ray that goes away from the normal axis. Now here in the second diagram we can see that the angle at which, the incident angle at which the refraction, the angle will be around the 90 degree. So you can see that this is what it is known as the critical angle, and here you can see it's the angle, okay, that is the theta 1 and the theta 2, okay, and now they both are in the same medium and the total internal reflection that could occur. So it is about the critical angle. So at a certain angle of incidence, the angle of the reflection that becomes the 90 degree, and this is referred to as the critical angle. So critical angle can be calculated from the Snell's law. What we can do? Our equation is the n1 sin theta 1 is equal to n2 sin theta 2. Now what we should do? The refracted angle that should become the 90 degree to calculate the critical angle. So we are putting that 90 degree of the angle as the refracted angle. So now that gives us like this. So it's n1 sin theta 1 is equal to n2 sin theta 2. So theta 2 is 90 degree. At that time what could be the incidence angle? That becomes the critical angle. So it is the theta 1 is equal to theta c. So it is the n1 sin theta 1 is equal to n2 sin 90. So but sin 90 is 1. So we can put this value over here and we can find it out. n1 sin theta 1 is equal to n2. So we can write what? Theta 1 is equal to sine inverse n2 by n1, or we can write arc sine n2 by n1. What is it? It's a theta c. So it's a critical angle. So therefore the actual value of the critical angle, that is depending upon the combination of the materials present on each side of the boundary. So this is about the reflection, refraction and the Snell's law. Now the important aspects used in the optical fiber communication, that is total internal reflection. So if the light hits the interface at the angle, okay, at any angle larger than the critical angle, then it will not pass through to the second medium at all, and the signal, the particular ray, that will be reflected to the first medium. So it is referred to as a total internal reflection. So total internal reflection is, if the angle of incidence is increased than the critical angle, then the light ray gets reflected rather than causing the refraction. Okay, so here you can see the diagram. Okay, that is what medium 1 and the medium 2. Reflected wave, okay, passes from, okay, the medium 2, okay. What happened? That whenever the angle value that is greater than the 90 degree, that all comes into this particular medium 1. So here what we have? We have the total internal reflection. Okay, so now the total internal reflection that can be used in the optical fiber communication. So now the incident angle while less than the refractive critical angle. Okay, so now here you can see that the normal axis we have, okay, the medium refractive index, okay, that is suppose the N2, here the refractive index, that is the N1. Okay, now the light ray will passes from this N1 medium, okay, and what happened? This is my incident ray. Now when it passes from the one medium to the another medium, okay, what happened? The light ray, okay, that gets the band and it goes to the another medium. So it is the refracted ray. The angle of the incident is the theta 1, angle of incidence refraction, that is the theta 2. Okay, so it is the one thing, that is incident angle, the less than. Okay, now the when what happened? That the reflected ray that would be like this. Okay, so it is about this. Now when the critical angle, what is this? The critical angle means the incidence angle. Okay, now it is less than the exactly the 90 degree. So N1, N2 incidence ray make the angle with the normal axis. It's a theta 1. Now when it is refracted ray, it's a 90 degree. Okay, it is referred to as the critical angle. So this is when the theta 2 value, that is the 90 degree, it is referred to as the critical angle. Incidence angle greater than the critical angle. Okay, so now when it greater than it, what will happen? Its normal axis, refractive index is N2 and N1 incidence angle will make the angle, okay, with the normal, it is the theta 1, okay, while the incidence angle greater than the critical angle, what will happen? The refracted ray which you will get in the same medium, okay, and it will make the angle, okay, that is suppose the theta 2. Okay, so this is about the how the wave, okay, that will be change, okay, and how the wave that go refracted ray that bends toward the normal go away from the normal and exactly onto the normal axis. So it is about the various aspects related to the fiber optic communication. So thank you very much everyone.